Welcome student. Today we are studying chapter number 1 of 9th standard, basic concepts in geometry.
Standard 9 Mathematics Part 2 Chapter number 1 Basic Concepts in Geometry.
Introduction.
Did you recognize the adjacent picture? It is a picture of pyramids in Egypt, built 3000 years before Christian era. How the people were able to build such huge structures in so old time? It is not possible to build such huge structures without developed knowledge of geometry and engineering. The word geometry itself suggests the origin of the subject. It is generated from Greek words geo, which means earth, and metria, which means measuring. So, it can be guessed that the subject must have evolved from the need of measuring the earth, that is, land. Geometry was developed in many nations in different periods and for different construction. The first Greek mathematician, Thales, had gone to Egypt. It is said that he determined height of a pyramid by measuring its shadow and using properties of similar triangles. Ancient Indians also had deep knowledge of geometry. In Vedic period, people used geometrical properties to build altars. The book Shulva Sutra describes how to build different shapes by taking measurements with the help of a string. In course of time, the mathematicians Aryabhatta, Varahamihir, Brahmagupta, Bhaskaracharya, and many others have given valuable contribution to the subject of geometry. Let's learn basic concept in geometry, that is, point, line, and plane. We do not define numbers. Similarly, we do not define a point, line, and plane also. These are some basic concepts in geometry. Lines and planes are set of points. Keep in mind that the word line is used in the sense straight line. Coordinates of points and distance. Observe the following number line. Here, the point D on the number line denotes the number 1. So, it is said that 1 is the coordinate of point D. The point B denotes the number -3 on the line. Hence, the coordinate of point B is -3. Similarly, the coordinate of point A and E are -5 and 3 respectively. The point E is 2 units away from point D. It means the distance between points D and E is 2. Thus, we can find the distance between 2 points on a number line by counting the number of units. The distance between point A and B on the above number line is also 2. Now, let us see how to find distance with the help of coordinates of points. To find the distance between 2 points, consider their coordinates and subtract the smaller coordinate from the larger. The coordinate of point D and E are 1 and 3 respectively. We know that 3 is greater than 1. Therefore, distance between point E and D is equal to 3 minus 1, which is equal to 2. The distance between E and D is denoted as distance ED. This is same as length ED. That is the length of the segment ED. Distance ED is equal to 3 minus 1, which is equal to 2. Therefore, length of ED is equal to 2. Distance ED is equal to length of ED, which is equal to 2. Similarly, distance of DE is equal to 2. Distance of CD is equal to 1 minus 2 in brackets, which is equal to 1 plus 2, which is equal to 3. Therefore, distance of CD is equal to length of CD, which is equal to 3. Similarly, distance of DC is equal to 3. Now, let us find distance of AB. The coordinate of A is minus 5 and that of B is minus 3. Minus 3 is greater than minus 5. Therefore, distance of AB is equal to minus 3 minus 5 in brackets, which is equal to minus 3 plus 5, which is equal to 2. From the above example, it is clear that the distance between two distinct points is always a positive number. Note that if the 2 points are not distinct, then the distance between them is 0. Remember this. The distance between 2 points is obtained by subtracting the smaller coordinate from the larger coordinate. The distance between any 2 points is a non-negative real number. Betweenness. Let's learn. If P, Q, R are 3 distinct collinear points, there are 3 possibilities. 1. Point Q is between P and R. 2. Point R is between P and Q. 3. Point P is between R and Q. If distance of PQ plus distance of QR is equal to distance of PR, then it is said that point Q is between P and R. The betweenness is shown as P dash Q dash R. Let's see some solved examples. Example 1. On a number line, point A, B and C are such that distance of AB is equal to 5. Distance of BC is equal to 11. And distance of AC is equal to 6. Which of the points is between the other two? Solution. Which of the points A, B and C is between the other two can be decided as follows. Distance of BC is equal to 11. Let us mark this equation as 1. Distance of AB plus distance of AC is equal to 5 plus 6, which is equal to 11. Let us mark this equation as 2. Therefore, distance of BC is equal to distance of AB plus distance of AC. From equation 1 and 2. Point A is between point B and C. Example 2. U, V and A are three cities on a straight road. The distance between U and A is 215 kilometers. Between V and A is 140 kilometers. And between U and V is 75 kilometers. Which of them is between the other two? Solution. Distance of UA is equal to 215. Distance of VA is equal to 140. Distance of UV is equal to 75. Distance of UV plus distance of VA is equal to 75 plus 140, which is equal to 215. Distance of UA is equal to 215. Therefore, distance of UA is equal to distance of UV plus distance of VA. Therefore, the city V is between the cities U and A. Example 3. The coordinate of point A on a number line is 5. Find the coordinate of point on the number line which are 13 units away from A. Solution. As shown in the figure, let us take point T and D to the left and right of A respectively at a distance of 13 units. The coordinate of point T, which is to the left of A, will be 5 minus 13, which is equal to minus 8. The coordinate of point D, which is to the right of A, will be 5 plus 13, which is equal to 18. Therefore, the coordinate of points 13 units away from A will be minus 8 and 18. Verify your answer. Distance of AD is equal to distance of AT, which is equal to 13. Activity 1. Point A, B, C are given a side. Check with a stretched thread whether the 3 points are collinear. Write which of them is between the other two. 2. Given a side are 4 points P, Q, R and S. Check which 3 of them are collinear and which 3 are non-collinear. In case of 3 collinear points, state which of them is between the other two. 3. Students are asked to stand in a line for mass drill. How will you check whether the students standing are in a line or not? 4. How had you verified that light rays travel in a straight line? Recall an experiment in science which you have done in a previous standard. Practice set 1.1. 1. Find the distances with the help of number line given below. 1. Distance of B, E. Solution. Coordinate of point B is 2. Coordinate of point E is 5. 5 is greater than 2. Therefore, distance of BE is equal to 5 minus 2, which is equal to 3. Answer. Distance of BE is equal to 3. 3. Distance of PC. Solution. Coordinate of point P is minus 4. Coordinate of point C is 3. 3 is greater than minus 4. Therefore, distance of PC is equal to 3 minus 4 in brackets, which is equal to 3 plus 4, which is equal to 7. Answer. Distance of PC is equal to 7. 5. Distance of KO. Solution. Coordinate of point K is -3. Coordinate of point O is 0. 0 is greater than -3. Therefore, distance of KO is equal to 0 minus -3 in brackets, which is equal to 0 plus 3, which is equal to 3. Answer. Distance of KO is equal to 3. 7. Distance of PJ. Solution. Coordinate of point P is -4. Coordinate of point J is -2. -2 is greater than -4. Therefore, distance of PJ is equal to -2 minus -4 in brackets, which is equal to -2 plus 4, which is equal to 2. Answer. Distance of PJ is equal to 2. 2. If the coordinate of A is x and that of B is y, find distance of AB. 1. X is equal to 1. Y is equal to 7. Solution. Coordinate of point A is x is equal to 1. Coordinate of point B is y is equal to 7. 7 is greater than 1. Therefore, distance of AB is equal to 7 minus 1, which is equal to 6. Answer. Distance of AB is equal to 6. 3. X is equal to -3. Y is equal to 7. Solution. Coordinate of point A is x is equal to -3 and coordinate of point B is y is equal to 7. 7 is greater than -3. Therefore, distance of AB is equal to 7 minus -3 in brackets, which is equal to 7 plus 3, which is equal to 10. Answer. Distance of AB is equal to 10. 5. X is equal to -3. Y is equal to -6. Solution. Coordinate of point A is x is equal to -3 and coordinate of point B is y is equal to -6. -3 is greater than -6. Therefore, distance of AB is equal to -3 minus -6 in brackets, which is equal to -3 plus 6, which is equal to 3. Answer. Distance of AB is equal to 3. 3. From the information given below, find which of the point is between the other two. If the points are not collinear, state so. 1. Distance of PR is equal to 7. Distance of PQ is equal to 10. Distance of QR is equal to 3. Solution. Given. Distance of PR is equal to 7. Distance of PQ is equal to 10. Distance of QR is equal to 3. Distance of PR plus distance of QR is equal to 7 plus 3, which is equal to 10. Distance of PQ is equal to 10. Therefore, distance of PR plus distance of QR is equal to distance of PQ. Therefore, points P, R, Q are collinear, and point R is between point P and Q. 2. Distance of RS is equal to 8. Distance of ST is equal to 6. Distance of RT is equal to 4. Solution. Given distance of RS is equal to 8. Distance of ST is equal to 6. Distance of RT is equal to 4. Distance of ST plus distance of RT is equal to 6 plus 4, which is equal to 10. Distance of RS is equal to 8. Therefore, distance of ST plus distance of RT is not equal to RS. Therefore, points R, S and T are not collinear. 5. Distance of XY is equal to 15. Distance of YZ is equal to 7. Distance of XZ is equal to 8. Solution. Given distance of XY is equal to 15. Distance of YZ is equal to 7. Distance of XZ is equal to 8. Distance of YZ plus distance of XZ is equal to 7 plus 8, which is equal to 15. Distance of XY is equal to 15. Therefore, distance of YZ plus distance of XZ is equal to distance of XY. Therefore, points X, Y and Z are collinear. Point Z is between point X and Y. 4. On a number line, point A, B and C are such that distance of AC is equal to 10. Distance of CB is equal to 8. Find distance of AB considering all possibilities. Solution. Given distance of AC is equal to 10. Distance of CB is equal to 8. Possibility 1. C lies between A and B, that is, A dash C dash B. Distance of AB is equal to distance of AC plus distance of CB, as A, C and B are collinear. Therefore, distance of AB is equal to 10 plus 8, which is equal to 18. When C lies between A and B, distance of AB is equal to 18. Possibility 2. B lies between A and C, that is, A dash B dash C. Distance of AC is equal to distance of AB plus distance of BC, as A, B and C are collinear. Therefore, 10 is equal to distance of AB plus 8. Therefore, distance of AB is equal to 10 minus 8, which is equal to 2. When B lies between A and C, distance of AB is equal to 2. Answer. Distance of AB is equal to 18 or 2. 6. Sketch proper figure and write the answer of the following questions. 1. If A dash B dash C and length of AC is equal to 11, length of BC is equal to 6.5, then length of AB is equal to how much? Solution. Length of AB is equal to 11. Length of BC is equal to 6.5. Length of AB plus length of BC is equal to length of AC, as A dash B dash C. Therefore, length of AB plus 6.5 is equal to 11. Therefore, length of AB is equal to 11 minus 6.5. Answer. Length of AB is equal to 4.5. 2. If R, S, T are collinear and length of ST is equal to 3.7, length of RS is equal to 2.5, then length of RT is equal to how much? Solution. Length of RS is equal to 2.5. Length of ST is equal to 3.7. Length of RS plus length of ST is equal to length of RT, since R, S and T are collinear. Therefore, 2.5 plus 3.7 is equal to length of RT. Answer. Length of RT is equal to 6.2. A segment, array and a line as sets of points. Let's learn. In the book Mathematics Part 1 for Standard 9, we have learnt union and intersections of sets in the topic on set. Now, let us describe a segment, array and a line as sets of points. 1. Line segment. The union set of point A, point B and points between A and B is called segment AB. Segment AB is written as seg AB in brief. Segment AB means segment BA. The point A and B are called endpoints of segment AB. The distance between the endpoints of a segment is called the length of the segment. That is, length of AB is equal to distance of AB. Length of AB is equal to 5 is also written as AB is equal to 5. 2. Ray AB. Suppose A and B are two distinct points. The union set of all points on segment AB and the points P such that A dash B dash P is called ray AB. Here, point A is called the endpoint of ray AB. 3. Line AB. The union set of point on ray AB and opposite ray of AB is called line AB. The set of points of segment AB is subset of point line AB. 4. Congruent segment. If the length of two segments is equal, then the two segments are congruent. If length of AB is equal to length of CD, then segment AB is congruent to segment CD. 5. Properties of congruent segment. 1. Reflexivity. Segment AB is congruent to segment AB. 2. Symmetry. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. 3. Transitivity. If segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is also congruent to segment EF. 6. Midpoint of a segment. If A, M, B and segment AM is congruent to segment MB, then M is called the midpoint of segment AB. Every segment has one and only one midpoint. 7. Comparison of segment. If length of segment AB is less than the length of segment CD, it is written as segment AB is lesser than segment CD, or segment CD is greater than segment AB. The comparison of segment depends upon their lengths. 8. Perpendicularity of segments or rays. If the lines containing two segments, two rays, or a ray and a segment are perpendicular to each other, then the two segments, two rays, or the segment and the ray are said to be perpendicular to each other. Segment AB is perpendicular to line CD. Segment AB is perpendicular to ray CD. 9. Distance of a point from a line. If segment CD is perpendicular to line AB and the point D lies on line AB, then the length of segment CD is called the distance of point C from line AB. The point D is called the foot of the perpendicular. If length of CD is equal to A, then the point C is at a distance of A from the line AB.